So we have an 1850 kilogram car stopped, so that would be a velocity, is hit by a 975 kilogram truck. The truck's velocity was 22 meters per second before the collision, so that would be initially, before the collision. What is the velocity? So what is the velocity of the entangled mass after the collision? So we are looking for the velocity final of the entangled mass. So that would be both of them. That's what we're solving for. First thing I'm going to do is I'm going to draw a picture. So we're going to start out. We have a car, and it is just sitting there. Wow. So a car, and it's just sitting there, and then a truck is going to come up and just drill it. Okay, so here's a poor little car with velocity of 0 to begin with, and then velocity is 22 meters per second. And he's just going to drill it. So what I'm going to do first, draw a little chart. We're going to have our initial, so this is before the collision, is the initial. After the collision is going to be our final. So initially, I'm going to draw, we have the truck. Yep, truck. And so its velocity is 22 meters per second. And then the mass of the truck, if we look at the problem, it said it was 975 kilograms. So we got 975 kilograms is the mass of the truck. Notice we're going to have separate pictures because they're going at different velocities at the beginning. So notice we have velocity is 0 and then velocity is 22 meters per second. So we need to put a plus sign in between our two pictures. So now I'm going to draw our car. It's a beautiful car. And it's going to start with a velocity of 0 meters per second. And then the mass is 1850 kilograms. Holy cow, it needs to go on a diet. It is bigger than the truck. So we have the initial, now we need the final. So for the final it says, what is the velocity of the entangled mass? And so what's going to happen is it's going to be both the mass of the truck and the mass of the car. So we're going to actually have to add those two masses up together, and that will get us the mass of our final picture. So 975 and 1850, 2825. So I'm going to use a different color. I'm going to use green. And so we're going to have a truck car. So truck car, I'm just going to put the car on top. We have a truck car. So the mass was 2825 kilograms, pretty sure. And we are solving for its velocity. Remember, plus signs in between pictures. When we get to this line that separates initial and final, we need to put an equal sign. So here is our equal sign. Okay, so the initial and final, this picture, pretty much replaces our givens and our unknown. Real quick, I'll just write out our givens and our unknown just for those of you that like to keep doing that. That's absolutely fine. So we have velocity, 22 meters per second. Notice I'm not using subscript. The reason is because I would much rather just color code it than to use subscripts because it gets pretty messy if you're using subscripts. So I just like to color code. That I would encourage you to do it as well. And so I'm just copying that information from above to down here. So now we're going to have the mass is 2825 kilograms. Our unknown is going to be velocity. It's going to be velocity final because it's on the final side. And notice it should be in green because it is of the truck car. For our equation, if you look at this picture, where we have two different velocities and we have a plus sign. So we would need a plus sign in between our two different velocities on the left-hand side of the equation. So if we look at this equation, look, it's a mass and velocity plus a mass and velocity. Okay, we could use that. Mass and velocity plus mass and velocity. We could use that. Notice the third one has just the same velocity for both objects at the beginning, That's not the case for this, so you definitely cannot use this equation. Okay, so now we're down to 1 and 2. Now if you look at equation 1, it has mass and velocity final and mass and velocity final. Notice this has only one final velocity, so it's not going to be 1 or 3, so it must be number 2. So we're going to use equation number 2. Again, I'm going to color code it. Red is going to be, this would be object 1. Orange is going to be object 2. And then object 3 is just going to be this one. So I'll write that equation down real quick, and I'm going to color code it. So we're going to have M1 VI1 and plus M2 VI2 is going to equal, going to our third object, so it's going to be in green, VF. It's going to be mass of object 1 plus mass of object 2. Notice we already added those together, so we're just going to plug that number in instead of adding them. Or you can plug those in, it really doesn't matter. But I'm just going to, since I already added them, I'm just going to plug it in for that whole value. So now, notice we're solving for the velocity in green. This is the only velocity in green. So to get velocity by itself, we're going to divide by the mass of object 1 plus object 2. So we're going to divide by both sides. We're going to divide this by M1 plus M2. Notice it should be in parentheses. Divide by M1 plus M2. This is going to cancel out on the right side. We'll be left with just velocity final. Because I have a whiteboard and I can do this, you probably can't. I'm just going to erase this real quick. Just because I'm running out of room. And now I'm going to copy down our actual values so we can solve for this. So mass of the red color would be 975 kilograms. Velocity of the red is 22 meters per second. Plus the orange is 1850 kilograms. 0 meters per second. Divided by the mass of the third color, which mass object 1 and object 2, which is going to be 2825 kilograms. So if you plug that into your calculator, you should get an answer of 7.59 meters per second.